Hello everyone, welcome back to DeeperBits. My name is Rohit Raj. So in our previous lecture, we have basically learned two important concepts. So the first important concept that we have learned is every file is stored as blobs and blobs are shared across versions if they are not changed. Now the second very important concept that we have learned in our last lecture is for every folder we should create a tree data structure. So let's say for a version, if we have two folders, then the total number of tree data structure will be 3. Like for every folder we have one tree data structure and we have one final tree data structure from which we will get a one single hash. I just want to introduce one more concept with you guys is this single hash is also called as commit IDs. So let's say in my feature video, if I call this single hash as a commit ID, then please remember the single hash of that version or the commit ID, both are basically same. So after learning these two concepts, now I wanted to ask a question. Have we really solved the problem that we have faced in our first lecture of version control system intuition, that is of disk space, now as we are reusing the blob across versions, right? So let's see. So let's say for every version you are creating one blob, and let's say that blob is of 1 GB, and let's say when you are creating the second version, you are just making changes in KBs, and then again it will create a new whole blob, right? So for 50 versions we have 50 blobs, and let's say for 1000 versions we have 1000 blobs, and each blob is of 1 GB plus minus KBs, and then again it is of 1 TB and we will again run out of disk space. So if you are realizing this correctly, actually we are not able to solve the problem even if blobs are shared, because in worst case scenario what will happen is your one blob is very big, like your base blob is basically a 1 GB, and you are making changes in KBs every time when you are creating a new version, and let's say you created 1000 versions, and then you'll again run out of disk space. So sharing blobs actually doesn't work in the worst case scenario. So how we can solve this problem? So I have one idea. So what we can do it is, let's say we have one version v1 where we have 3 blobs and we have a tree data structure, and from now on what I'm going to do is I'm going to call these blobs and trees as objects, right? So let's say we have 3 blob objects and we have one tree object, and uh, how we can basically store it efficiently. So I think there is one way to store the blobs efficiently, that is called as compression. So for all these 3 blobs and basically one tree, we will compress. These are basically files only, right? So what we can do is we can basically compress these files and we can basically store it. So let's say, then again we come with the same question. Let's say we have 1000 versions and we have basically 1000 blobs, and each blob is of approximately 1 GB, and let's say we are able to compress it to 100 MB. So it will become 1/10, right? I mean, from 1 GB, that is 1000 MB, to 100 MB, so it will become 1/10. So for every file, if we are able to compress to its 1/10, then the total space is basically 1 TB, and if we take 1/10 of it, then it will become 100 GB. So yeah, if we are able to, if we use the compression algorithm and if we are able to compress these objects, then what will happen is from basically 1 TB we will come down to 100 GB, and this will actually help us to save lot of disk space. Now I have one more idea actually. So now try to understand it very carefully, because this concept is little bit tricky and little bit tough. So let's say, now let's not talk about versions, let's talk in blobs only. So let's say you have total 50 blobs. Let's say you have some versions that has created blobs, and let's say you have total 50 blobs, right? Now let's say you created one more version and it has created the 51st blob. So I have one idea is, can we do something? Can we create a delta file? But I don't want to create the delta file of the 51st blob. I mean the new blob that is created. I want to create the delta file of the first blob. So what I will do is, let's say for we have initially 50 blobs. We have created a version that has created the 51st blob, and then what we do is we basically created the delta file of the first blob, and basically it will reduce the disk space because now you have only delta file for the first blob, right? Now I'm little bit confused here. Let's say my first blob is the delta file, then what is the base file? So what I am doing behind the scene is, let's say I have my second blob and I have my first blob. What I am doing it is, I am taking the second blob as the base file, and for the first blob I'm creating the delta file. Now let's say what I do is I created another version and it has created 52 blobs. So from second to 52 blob, I have all the blobs, and the first blob is the delta file. Now what I will do is, for the second blob I will again create a delta file. So what I will do is, I will keep the third blob as the base file, and then for the second blob I will create the delta file, right? And let's say now you ask me like, Rohit, how will you get the second blob? So what I will do is, I will take the third blob which is my base file, and I will basically add the delta file which is the second blob, and I will get the second blob. Now let's say I want to get the first blob. So how I can get it? So my base file is the third blob. So what I will do is, I will take the base file as third blob, and then I will merge the delta file which is the second blob, and then I will merge again the delta file which is the first blob, and this will give the actual first blob. Now you ask me, right, why we are doing this, like why we are creating the delta file from the lower like from downwards, like why we are not creating from upwards. So see this, let's say for every blob you have one version. Let's assume that is the case, right? So let's say you have total 52 versions. So you have 52 blobs, right? And you have the first version, which is basically the first blob, which is the delta blob. Now for the second version, you have basically the blob, which is basically the delta blob, and you are at the 52nd version. Now I just wanted to ask you, think it practically, like what is the scenario, like you come from 52nd version to the second version, like you will roll back these many times. It's very rare, right? So that's why in our version control system, basically what we are doing it is, we are creating the delta files from downwards, because it's very rare like will come this much down. And let's say when we are coming this much down, like let's say in worst case scenario, we came from the 52nd version and we roll back to our second version. We have to do the computation, I mean we have to do the merging only one time, right? And then let's say I come at the first version, so I have to do the merging only two times, like from third base file I am merging the second delta blob, and then I'm merging the first delta blob, so only two times, right? So do you remember we have discussed it, like doing merge so many times is very hard, so we have to minimize the merging, and we have to also optimize our space. So what we can do it is, we can basically keep our create the delta files in a reverse manner, I mean from the downwards, and we can also keep a max chain length of 50. It means is we can't create more than 50 delta files. Let's say from 52 we reach out to basically 1000 blobs, then also our basically let's say we reach out to 1000 blobs, then also our delta files are only from 1 to 50, and from 51 we will have the full blob, because if we increase the max chain length to more than 50, and in worst case scenario if we reverse back from the 1000th version to the first version, then basically we have to do only 50 times the merging operation, right? So now you are understanding it, right? The concept of compression that we have introduced, we are already using it. I mean, every blob we are compressing it, every tree object we are compressing it. Now the second very important thing that you understand in our first lecture is to creating the delta files. And now what we are doing is, we are not creating the delta files of the fresh blobs, we are doing it actually in reverse manner, and we are creating the delta files from downwards, and this will actually reduce the disk space. I mean, so let's think it like that. Let's say you have a blob of 100 MB, right, after compression, and then you created a delta file and you are making changes in kbs only, so the delta file is in kb, and then you again compress it, so it will become very less, right? So from 100 MB, the delta file that you have created, let's say for the second blob, it will change into kbs. For the first blob that you have created delta file, it will change into kbs. And we have also keep a check of max length of 50 only. I mean, if we increase it to 100 or 200, then maybe computationally for our computer it becomes very hard, and we will again face a computing problem. So we have keep a max length or max chain length of delta files is of 50 only, and that what Git does behind the scenes. So now from the first lecture we have faced the disk space issue. So we have applied the compression, we have applied basically reusing of blobs if they are not changed, and we have applied the third idea of basically creating the delta files as well, but from downward manner. So now we have actually solved our problem, that whatever the problems that we faced in our first lecture of version control system intuition, we have actually solved it. So I just want all of you guys is think about it. It is little bit tricky and hard to understand, and if you are really not getting it, then try to rewatch this video again. So at last I wanted to tell you guys, if you are really liking my video, if you are really liking the content, you can subscribe to my channel, and you can follow me on Insta and Twitter for frequent updates. Thanks a lot. Thank you very much.